DeepSeek-Coder was released in 2024 and now in 2025 we are seeing its real impact on open source code intelligence. How has it evolved? How does it compare to closed source giants like Codex and GPT 3.5? Let's dive into what makes it a game changer. Medusa, a new framework introduced for LLM Inference acceleration, takes a different approach by adding multiple decoding heads to an existing LLMs. Medusa can generate multiple tokens in parallel. So using a tree-based attention mechanism, Medusa constructs multiple candidate continuation for each decoding steps and evaluates them simultaneously. Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, in this episode, we are just going to discuss on large language models. Yes, the field of artificial intelligence, driven code intelligence has long been dominated by closed source models, limiting research, customization, and accessibility. While models like Codex and GPT 3.5 have demonstrated impressive code generation capabilities, their restricted availability has stifled broader innovation in AI-assisted programming. With the introductions of DeepSeek-Coder, the paradigm is shifting by offering open source model ranging from 1.3B to 33B parameters trained on an extensive 2 trillion tokens datasets. So DeepSeek-Coder levels the playing field for developers, researchers, and businesses. This advancement is more than just an alternative to proprietary models. It marks the beginning of a new era where AI-driven code tools are transparent, adaptable, and wide accessible. Beyond DeepSeek-Coder, frameworks like Unitxt enhances the reusabilities of generative AI data pipelines, while Medusa accelerates LLM inference through multi-head decoding, making AI-powered coding tools faster and more efficient. Meanwhile, benchmarks like ConTextual help evaluate AI's reasoning abilities, ensuring that models improve in practical, real-world coding scenarios. This collective shift towards open source and efficiency-driven AI is setting the foundation for smarter, faster, and more collaborative software development. Yes, dear friends, today we are just going to see all these collections of LLMs. So let me just go on to the first paper, DeepSeek-Coder. When the large language model meets programming, the rise of code intelligence. Dear friends, the arrival of large language models has been revolutionary in many fields, especially natural language processing, and its impact on programming is undeniable. However, most of the models in the programming space, such as Codex or GPT 3.5, have been closed source, making them inaccessible for extensive research and fine-tuning by the broader community. This limits innovation in code generation, bug detection, and software development processes. DeepSeek-Coder was released in 2024 and now in 2025 we are seeing its real impact on open source code intelligence. How has it evolved? How does it compare to closed source giants like Codex and GPT 3.5? Let's dive into what makes it a game changer. DeepSeek-Coder changes this by offering a series of open source models ranging from 1.3B to 33B parameters, providing a level of flexibility and access previously unseen in the field. DeepSeek-Coder is pre-trained on an enormous code corpus of 2 trillion tokens, sourced from a wide range of high-quality projects. The training methodology itself is unique, utilizing a fill-in-the-blank task that allows these models to better understand and generate code in a way that mimics the developer's thought process. This task not only strengthens the model's coding ability but also allows them to better handle ambiguous and incomplete information, something crucial for real-world development. When tested across various benchmarks, DeepSeek-Coder models have outperformed existing closed-source models such as Codex and GPT 3.5, establishing new benchmarks for what open source models can achieve in the field of code intelligence. What makes DeepSeek-Coder especially compelling is that it comes under a permissive license, which means that researchers or developers and even businesses can use it without restriction for both academic and commercial purposes. This democratization of access is set to fuel innovation in software development, making it a vital tool for everyone working in code generation, debugging, and automated software creation. The next paper, it is Unitxt Flexible, Shareable, and Reusable Data Preparation and Evaluation for Generative AI. Dear friends, in the world of generative AI, particularly in natural language processing, one of the primary challenges has been creating an efficient, flexible, and reusable data preparation pipeline. Most traditional text processing systems are highly tailored to specific datasets or models, making it difficult for researchers to easily share, replicate, or modify their workflows. The complex nature of generative tasks such as system prompts, model-specific formats, and instructions makes it even harder to maintain flexibility and reproducibility in natural language processing research. Unitxt addresses this challenge by offering a modular customization and shareable library for data preparation and evaluation designed specifically for generative language model. It breaks down the often complicated process of data pre-processing into individual, easy to manage components that can be independently customized and recombined as needed. So this approach ensures that researchers and practitioners can tweak the data pipeline to fit their unique models, tasks, and dataset without having to reinvent the wheel each time. Unitxt integrates seamlessly with popular libraries like Hugging Face and LLM Eval Harness, two well-established tools in natural language processing space. So it also provides a flexible infrastructure for managing different components from model-specific format to task prompts and dataset processing. The real power of Unitxt lies in its catalog, which acts as a centralized hub for sharing data preparation components, fostering collaborations within the community. So researchers can share best practice, reuse each other's works, and even build on existing components to quickly iterate on new ideas. So this collaborative and open environment helps accelerate and progress in generative AI, making Unitxt a vital tool for anyone working in the field. Next paper, it is Medusa, Simple LLM Inference Acceleration Framework with Multiple Decoding Heads. Dear friends, this inference process in large language model is inherently slow due to the auto-regressive decoding mechanism, where each token is generated one at a time, requiring significant computational resource and time. So this bottleneck is further compounded by the limitation of accelerator memory bandwidth. While techniques like speculation decoding have been proposed to speed up inference, these methods often come with their own challenges, including the need for an additional draft, model, and complex integration. Medusa, a new framework introduced for LLM inference acceleration, takes a different approach by adding multiple decoding heads to an existing LLMs. Medusa can generate multiple tokens in parallel. So using a tree-based attention mechanism, Medusa constructs multiple candidate continuation for each decoding steps and evaluates them simultaneously. So this parallelism leads to a significant reduction in the number of decoding steps needed to generate a complete sequence. So thus speeding up the entire inference process. Medusa comes with two fine-tuning procedures to meet different use cases. As Medusa 1, which fine-tunes the decoding heads on top of the frozen LLM backbone, and Medusa 2, which fine-tunes both the decoding heads and the backbone LLM for improved accuracy and further acceleration. The result is an LLM that is not only faster but also more efficient. In experiments, Medusa 1 has achieved over 2.2x speed up in inference time without sacrificing quality, while Medusa 2 pushes the speed up even further to 2.3x to 3.63x. So this makes Medusa an attractive option for applications that require real-time inference or processing large volume of text quickly. Okay, moreover, Medusa introduced several enhancements such as self-distillation for scenarios where training data is sparse and a new acceptance scheme to improve the quality of generated content without compromising the speed. So these innovations pushes the envelope on what is possible in terms of efficient and high quality LLM inference, and they promise us to be a crucial part of the next wave of AI acceleration. The next paper is ConTextual, evaluating context-sensitive, text-rich visual reasoning in large multimodal models. Dear friends, multimodal models which combine both text and visual information are rapidly advancing, enabling AI system to handle more complex tasks that involve joint reasoning over text and images. For instance, applications like navigation, time reading, and visual shopping assistants require models to understand both the textual instructions and the visual elements in the environment. However, current large multimodal models still struggle with context sensitivity visual reasoning, which is crucial for interpreting complex real-world tasks. The contextual benchmark was designed to fill this gap by providing a structural framework to evaluate how well LLMs can handle context sensitivity. So text-rich visual reasoning. The contextual tasks range from time reading, for an example, interpreting the time shows on a clock. So time reading to more complex tasks like shopping or navigating through maps. These scenarios test a model's ability to combine text and visual context in meaningful ways. So what the author found in their evaluation was that the best performing multimodal model, that is examples like GPT-4 Vision, still lagged behind human level performance by a significant margin with a 30.8% gap in certain tasks. Interestingly, while GPT-4 version performed excellently in abstract tasks like meme or quote interpretations, it struggled with more practical context, context-sensitive visual reasoning. So this points to an ongoing challenge in multimodal AI. While these models can generate impressive results in certain contexts, they still have a long way to go in understanding real world So that interactions between text and visual information. And dear friends, the introductions of the contextual benchmark is a step towards improving these models, providing both a platform for evaluation and a framework for the future advancement of LLMs. These evaluations and findings offer critical insights that could inform the development of more contextually aware and accurate multimodal systems, driving improvements in everything from autonomous navigation to intelligent personal assistant. The next paper, it is Rethinking Patch Dependence for Masked Autoencoder. Dear friends, masked autoencoders, MAEs, have become a popular approach in self-supervised learning for vision tasks. The main idea behind this MAEs is to randomly mask portions of an image and then train the model to reconstruct the missing parts. Typically, the decoding mechanism of this MAEs relies on self-attention across masked patches, but this can be computationally expensive and may not be necessary for learning effective representation. In this work, the authors propose a novel approach called cross-MAE, which fundamentally alters the decoding mechanism by removing self-attention between the masked patches and instead focusing solely across attention between the masked and visual tokens. This adjustment not only simplifies the reconstruction process but also improves the overall efficiency of the model. The key innovation here is that cross-MAE's decoder can now only leverage cross-attention between masked and visible tokens. So this drastically reduces computational complex, especially in the decoding phase. As a result, cross-MAE is able to achieve 2.5 to 3.7 times less decoding compute compared to traditional MAEs, making it significantly more efficient despite this reduction in compute. Cross-MAE matches or even exceeds the performance of MAE on downstream tasks like ImageNet classification and COCO instance segmentation. Dear friends, this new approach is a breakthrough in self-supervised learning, as it provides an efficient way to learn visual representation without compromising on task performance by focusing on cross-attention and reducing unnecessary operations. Cross-MAE sets a new standard in the efficiency of masked autoencoders, enabling faster training and development of vision models. The next paper, it is Multimodal Pathway, Improve Transformers with Irrelevant Data from Other Modalities. Dear friends, the idea of combining multiple modalities such as text, image and audio has been a central theme in AI research. However, traditional multimodal system requires paired data, where the data is one modality has a corresponding counterpart in another. But the challenge here is that often this paired data is not available or is expensive to generate. The multimodal pathway approach offers a unique solution by utilizing irrelevant data from other modalities to improve a model's performance on a target modality. For an example, an image model trained for ImageNet classification could be improved using data from entirely different modalities, such as audio or point clouds, even if the data has no direct relationship with the images. So the key here is a cross-modal reparameterization method, which allows a modality-specific transformer model to benefit from an auxiliary transformer. So model trained on an unrelated modality. Essentially, this method exploits the universal sequence-to-sequence modeling ability of transformers across different domains. This technique doesn't require additional inference cost and instead repurpose the weights of the auxiliary transformer, allowing the image model to leverage insights from audio or point cloud datasets, even if the two modalities are not directly connected. This reparameterization improves the performance of the target, target model across tasks like image recognition, point cloud analysis, and audio recognition. Dear friends, this approach shows consistent and significant improvements, demonstrating the power of transformer to benefit from irrelevant data in an innovative and cost-effective way. The multimodal pathway opens the door to a new way of thinking about how models can learn from multiple sources, even when those sources seem unrelated. This could lead to more flexible and adaptable models which are less reliant on paired data, thus broadening the scope of multimodal learning and application in real-world environments. Dear friends, the democratizations of artificial intelligence-driven programming tool represents a profound transformation in the way we write, debug, and optimize code. Open source models like DeepSeek-Coder not only removes barrier to innovation but also encourage a global community of developers to refine and enhance AI-assisted coding. As acceleration frameworks like Medusa make LLMs inference more efficient and evaluation benchmarks like ConTextual push AI towards higher reasoning abilities. We are witnessing the rapid evaluation of intelligent programming assistant. With this momentum, the future of software development will be shaped by AI models that are not just powerful but also transparent, customizable, and universally accessible. The rise of code intelligence is here and it's open to everyone. Hope you enjoyed this deep dive. Let us know your thoughts in the comments below. And if you have come across any papers related to this topic discussed, feel free to share them with us. Don't forget to like, share, and subscribe for more updates on the world of generative AI and LLM. Thanks for watching and see you in the next episode. Happy learning, dear friends.